This video will show you how to write an equation of a line using the point-slope formula. You may have already watched the other videos where I teach you the same concept, but I use the slope-intercept form of a line to begin with. If you're not told which equation to use, you can use whatever one you want to start with. Sometimes the directions will specify that you must first write it in point-slope form and then convert it to slope-intercept form. So this right here is the point-slope form. Y minus y1 equals m times parentheses x minus x1. That's known as the point-slope form of a line because m is still your slope and the point is your x1, y1 that you would start with. Then sometimes you are told you have to put it into slope-intercept form. Any which way, whether you use the point-slope form or you use the slope-intercept form, you've got to have the slope. That's where you need to start. Sometimes you will have the slope given to you, and sometimes you have to do something to find it. So let's take a look at a couple examples. Write the point-slope form of the line's equation satisfying the given conditions. Then write it in slope-intercept form. So it says write the point-slope form. That's what we want to start with. There's our point-slope form. There's our slope, and of course slope is m. So this is our m equals 3. This is our point, x sub 1, comma y sub 1. So all we have to do is take this information and stuff it into this formula, and we will have half of the answer finished. So this is y minus y sub 1, which is 6, equals m, which is 3, times x minus x sub 1, which happens to be a negative 2. So clean this up a little bit. Minus a minus will give me plus. We want to convert it into this form, which means we need to solve for y and get rid of those parentheses. So I will have y minus 6 still over here. Distribute the 3 through the parentheses, and we have 3x plus 6. All that remains is for me to get the y alone by adding 6 to both sides. And we have y equals 3x plus 12. And that is the slope-intercept form of a line. So this is what you would enter on the computer for point-slope form, and this is what you'll enter for slope-intercept form. Same kind of problem. This time the slope is a fraction, but I still have to stuff into my point-slope form. This is x1, and this is y1, and this is your m. So this is y minus y1, which is 1, equals the slope, which is negative 2/3, parentheses x minus x1, which happens to be a negative 4. So I happen to have two negatives in a row here, change them both to plus, and this right here is your point-slope form. You're finished with that part. But to convert it to slope-intercept form, distribute the negative 2/3. Negative 2/3 times x is negative 2/3. Negative 2/3 times 4 is negative 8/3. And then all we have to do is get the y alone, add 1 to both sides. And most of you guys have calculators that do fractions for you. So this is y equals negative 2/3 x. You can type this directly in your calculator, negative 8/3 plus 1, and you will have negative 5/3. If your calculator does not do fractions and you need to change 1 to 3/3 so that you have a common denominator. So there is your slope-intercept form. There is your point-slope form. Same kind of problem, but this time says we have a line that is passing through these points. Do we have the slope? Remember on the first screen I said you've got to have the slope to get started. We do not have the slope, but we can find the slope very easily if you remember that slope is this formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to use these 2 points over here to find the slope. You might want to label this as x1, y1. And then label this as x2, y2 to help you plug in to find the slope. I always suggest with slope that you draw the line and that you also put those two negatives right there so that you remember that it is a minus. So then we plug in y sub 2 is 2, minus that we already have there, y sub 1 is 6. On the bottom, x sub 2 is 4, and then x sub 1 happens to be a negative 2. This is the reason I suggest you put that minus there in the beginning, because you have 2 in a row. The red one is there because the formula tells me to subtract. The blue one is there because the x sub 1 happens to be a negative. Clean this up a little bit. This goes to plus. 2 minus 6 is negative 4. 4 plus 2 is 6. Reduce it and we get the fraction negative 2/3. So you want to reduce your slope all the way out to a simplified fraction. And then we will plug in. So m is negative 2/3 x minus, now this actually says minus x sub 1, so you could just restrict yourself to this point, or you could use the other point if you wanted to. It doesn't matter. Just don't mix and match. Use this x and this y together, or use this x and this y together. I'll go ahead and use this one just because it does fit the formula of the x1, y1. So this is x minus x sub 1, which is negative 2. Over on this side, this is y minus 6. Distribute, or actually let's change this to plus. Distribute, negative 2/3 x minus 4/3, because negative 2/3 times 2 is negative 4/3. If you can't do that arithmetic in your head, you can type it into your calculator. And our last step is add 6 to both sides. Same thing I said on the last slide. Your scientific or graphing calculators will do the fractions for you. If you have to get a common denominator, the common denominator is 3. And then 6 would be the same thing as 18/3. So negative 4/3 plus 18/3 is 14/3. But if your calculator does fractions, you don't have to worry about doing that common denominator stuff. So here is your point slope form, and here is your slope intercept form. Similar problem, you may think it's more difficult, but it is not. First off, we're going to pass through the point 1,5, and it has x-intercept 2. Well, do we have the slope? And the answer is no, we don't have the slope. Nowhere in the problem does it say the slope is blank, so we're going to have to find the slope. To find the slope, we have to use this formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And you may think, wait a minute, I don't have 2 points. I've got 1 point right here. Here's my x1, y1. But if this is the x-intercept, you should recall that the x-intercept comes in this form. The x-intercept has an x value followed by 0. So the x-intercept is 2. That means the x value is 2, and the y value is 0. Because if it is the x-intercept, we're talking about the line crossing the x-axis. And at that point, you have an x value, but the y value is 0 because it's lying on that line. So this is my x2, y2. So telling you have an x-intercept of 2 is just kind of a tricky way of letting you know you have another point, specifically 2, 0. So let's plug into the slope formula. Here's my line. Here's my 2 minuses. And then let's start plugging in. y2 is 0, minus y1, which is 5. x2 is 2, x1 is 1. Do your arithmetic. 0 minus 5 is negative 5. 2 minus 1 is 1. And this just simplifies to the integer negative 5. Which is going to make the next steps easier. If your slope is an integer, the arithmetic is easier. So now I'm going to take this m, pairing it together with that, and I'm plugging into my point slope formula. So this is y minus y1, which is 5, equals m, which is negative 5, times x minus x1, which is 1. Distribute, negative 5x plus 5. So I have y minus 5. Undo this minus 5 by adding 5 to both sides, which gives you y equals negative 5x plus 10. This is your slope-intercept form, and this is your point-slope form. Write the equation line in point-slope form and then in general form. This is known as general form, very similar to standard form. General form has everything piled up on one side equal to 0. The a and the b are going to have to be integers, and the a must be a positive value. So we'll worry about that in a minute. Let's go ahead and use this information. Write the equation of the line in point-slope form. So we're going to have to start with our y minus y1 equals m times x minus x1. And you have to ask yourself, do we have the slope? We want to have it passing through 2, 5 and parallel to another line. You should recall that parallel lines have slopes that are the same. So we do have the slope. It's hidden, but we do know the slope. Parallel lines have the same slope. So if this line has a slope of 4/3, then my new line must also have a slope of 4/3. So I do have the slope. All I have to do is put that slope in for m, put my point in for y1 and x1, and I'm good to go. So m is 4/3 times x minus x1, which is 2. Over here, this is y minus 5. Same steps we've done before. Distribute this is 4/3 x minus 8/3, and this is y minus 5. Now, we want to go into general form. That means we want everything over here on one side equal to 0. The other thing I did not mention up here is that, well, I did say it. The other thing that's important is that we have integers for a, b, and c, meaning we got to get rid of these fractions. So what we always do to get rid of the fractions is multiply everything by the common denominator. Common denominator is 3, so I will multiply everything on this side by 3, multiply that by 3, multiply that by 3, which gives me 3y minus 15. Cancel out the 3's, gives me 4x, minus, cancel out the 3's, 8. And I'm still not there. I need everything piled up on one side equal to 0. So I will subtract 4x from both sides. I have negative 4x plus 3y. I will also add 8 to both sides, which gives me negative 7. The only other thing is that the rules require this to be a positive value. So if that's going to be positive, I must change all of these signs. So this is the same as 4x minus 3y plus 7 equals 0. And that is my general form. And the reason I went to that is because the directions told me to do that. I did not put it in slope-intercept form because that's not the form they want. So here's your general form, and then here is your point-slope form. Very similar problem. It's just this equation's just a little bit different. We are going to pass through this point. We want to be parallel to this line. Do you know what this slope is right off the top of your head? You may or may not. There is a nice little shortcut for getting the slope when it's in this form. To get the slope when it's in this form, one way to go, of course, is to totally rewrite the equation. Get the y alone, x and the number on this side. But there is a shortcut for coming up with the slope, and it is take the coefficient in front of x and change its sign, so I make it negative 2, over the coefficient in front of y. So it's the coefficient in front of x with a sign change divided by the coefficient in front of y. And that little shortcut only works if your x and y are together on the same side. This number right here doesn't matter a bit. A negative divided by a negative, of course, becomes a positive. And now let's plug into our point-slope formula. Y minus y1 equals m times x minus x1. Plug in your m of 2/5 times x minus x1, which is a negative 6. Over here, this is y minus negative 1. Both of these change to plus, and then I can distribute this. Is 2/5 x plus 12/5. Over here is y plus 1. Remember, we want to go into the general form, so I want everything piled up on one side equal to 0, and I'm not allowed to have fractions. So we're going to multiply everything by this common denominator of 5, and everything must be multiplied by the 5. So 5 times y is 5y. 5 times 1 is 5. On this side, the 5's cancel. We get 2x. And on this side, the 5's cancel, and we get 12. I'm going to do this a teeny bit different than the last time. I know I need everything piled up on one side, but I also need the x coefficient to be positive. Since it's positive on this side, I'm going to bring this stuff this way. So I will subtract 5y from both sides, which makes this a negative 5y. And I will subtract 5 from both sides, which is going to give me a 7. And technically, this would be equals 0 over here, but I'm going to put the 0 over here because that's the form I want it in. So this is our general form, and this up here was our point-slope form.